Hello, everyone. Welcome to the next lesson in chapter number 2, unit number 2. What we're going to be looking at today begins on page 7 in your notes, and we're going to look at some graphs, some particular types of graphs, linear, quadratic, one called cubic, and we're also going to look at a particular type of quadratic function. Remember, you get a parabola from a quadratic function, but we're going to look at one that opens sideways, which is a little different, but they do come up sometimes in various types of problems. So this is called graphs, and they're using the most basic of methods to actually draw the graph, making up a table of values. All right, so, and you can't get much more basic than that. What the very first time you ever drew a graph, that's probably what you did. So we're going to be making up a table of values, like I say, real easy. We're also going to be looking at something called the domain and the range of these graphs. Okay, now the domain, if you think of it carefully, the domain means all of the possible values of the independent variable. Now, for all of our graphs, that's going to be your x. And the range is all the possible values um, of the independent variable, which in our case is y. Now, you'll notice in the table of values, instead of putting a y there for the range, they've actually got f of x. But remember, that means the same thing as y. Okay? So here is the first, here is the first function that they want you to graph. F of x equals 3x subtract 5. And you probably recognize that as a linear function, which it is. It's just going to be a straight line. In fact, you know much better techniques for graphing this than just using a table of values. You may recall from Math 1700 that this equation is in what's called the slope-intercept form. So I can see that the y-intercept is going to be -5, and I can see that the slope of this graph, the rise over the run, is going to be 3 over 1. And you were graphing it using that technique in Math 1700. But all is required here is a table of values method. So without further ado, let me just have a look at the x's that they have in our table of values. They've decided to use -2, -1, 0, 1, 2. There's nothing special about those x values. You could have picked any x values you want, really. But that is a good selection right there because they have some negative numbers. They have some positive numbers. They have 0, right? They're all good values to put in a table of values. So if you use these numbers, take these x values, one at a time, plug them into your equation right there, okay? And you get the y values, or in other words, the f of x values. So if you plug in -2, now you can do these calculations on your own. I'm not going to show the actual calculations, but you're going to get back -11 for your y value. And that's a point now that you can plot, -2 and -11. Let me see, what would the next one become? If you plug in a -1 into your function, you're going to get back -8. Okay, if you plug in a 0, 0 is an easy one to plug in. You're going to get back -5. If you plug 1 in for x, you get back -2. And if you plug in a 2 for x, you're going to get back a +1. So let's go to our table, or let's go to our graph here now. Let me see. Okay, I can move down a little. And let's plot those points. All right. Now, by the way, if some of the points, if they're off your graph, if you can't see them, well, usually you don't really need to worry about that. If you have enough points there to see the shape of your graph, you can just use the points that are in your table. Or you may decide to scale your axes sometimes, and that's a wise choice sometimes. So -2, -11. Let me see here. -2. I go down 11 blocks, 2, 4, 6, 8, 10. Ooh, I go right to the bottom. Look at that. There's my first point. So just put a dot there. -1, -8 would be right here, approximately. 0 and -5, right here. And it certainly looks like these points are lining up linearly, don't they? And they are, because it's a linear function. 1 and -2 would be right here. You can clearly see your slope, your rise over your run, is 3 over 1. 2 and 1 would be right here. Okay? Now that's plenty of points. Take a ruler. Make sure you use a straight edge for this, everyone. Your graphs should be neat. And what you do is you lay your straight edge right along those points. Now, I can't use a straight edge here, but just pretend I am. Your graph should look something like, oops, that's off a little. Something like that right there. Now remember, you're going to use a straight edge. I can't use a straight edge here on my computer screen. I'd just end up with a mess. Now, I also said I'd like to talk about the domain and the range. What is the domain here? What is the range here? Remember, the domain is your x values, okay? Not just these x values, though. What are all of the x values? Every single one that's on that line, every single x value. If you started picking out points on this line, anywhere at all, to the left, to the right, you would see that every single x value has or every single point on the line has a corresponding x value. And in fact, for this graph, every single x value, every real number is somewhere on that line, everywhere. If, for example, if I pick 10 for x, where's 10 to? Way over here, look, there's 10. Now, I don't see a point on my line that has an x value of 10, but I guarantee you there's one there somewhere. It's way, way up to the right, okay, but it's there. So your domain is all real numbers. Here's how we write that. We write a curly bracket. All right, now if you can't write a curly bracket, don't worry about it. Write any bracket. We put in x because that's the independent variable here. And then we write a vertical line. We draw a vertical line, and that vertical line means such that. And then there is no restriction on x. X can be anything. So I just write x belongs to the set of real numbers. That little funny looking E symbol means belongs to or is an element of. And of course, the capital R, that's supposed to represent the real numbers. And this is just saying that x can be any real number. X can be anything. There's no restriction on it whatsoever. Now, if you also look at the y values, think about the y values. Well, again, you pick any point anywhere on that line. And I promise you that if you look to the left or look to the right, where is it hitting the y-axis? Every real number is also in the range. So my range here, all right, and I'm going to use a notation very similar to what I did up there, curly bracket, values of y, such that y belongs to the real numbers. So it can be anything. All right, so there's your domain and there's your range. We're going to continue with those as we look at these graphs. Getting the domain and range from a graph is actually not too bad. Okay, so here's the second function we're asked to graph. Now, you might recognize that, again, from your Math 1700 as quadratic. Here's the x values that they picked again. Okay, nothing special about them, but they're good ones, and some positive numbers, some negative numbers, and 0. Now, if you plug these into your function, one at a time, you will get back your y values, or your f of x values, and you'll actually get back, if you plug in -2, you get back y equals 4. If you plug in -1 for x, you will get back -2. If you plug in 0 for x, you'll get back -4. If you plug in 1 for x, you'll get back -2. Now look at that. You see that -2 value repeating there, right? But that's okay. It's still a function, right? Every single x only gives me back 1 y. And finally, if you plug in a 2, you get back a 4. So let's plot these points now on our graph. -2 and 4 would be right there, approximately. -1 and -2 is about there. And 0 and -4 is about there. You can see these aren't linear. 1 and -2 would be about there. And then 2 and 4, positive 2 and 4, would be up there. There you go. There's your parabola shape. So as carefully as you can, draw a nice curve through those points, like so. And there's your parabola. Okay, very straightforward. This parabola opens upward, of course, because the coefficient of your x squared is positive. Now the domain, what x values are actually in that graph? Well, what x values are you allowed to put in that equation is another way you could ask that. And basically you can put in anything that you like again. Every point, every x value on the x-axis, no matter how far left or how far right you look, has a point on that parabola. Okay, it will be there. So your domain is just like the domain in the last example. Values of x such that x is an element of or belongs to the real numbers. Now, what about the y values? That's your range. Okay, so we start off by writing a curly bracket, values of y such that. Now, let's look at some y values on our y-axis. Here's a y value. That y value is 3. Okay, now are there any points on that parabola that has a y value of 3? Well, yes, there are. If you look to the left, this point there has a y value of 3, and you can also look to the right. I got those backwards. And there's a y value of 3. There's actually two y values of 3. So 3 is in your range. There's a y value of 3 somewhere on that parabola. 2, same thing. 4, same thing. 5, 6, up to infinity. They all have a point somewhere on that parabola. In fact, and down, there's 0. There's y equals 0. And there's a point with a y coordinate of 0. And there's another point with a y coordinate of 0. And you can go all the way down there, but there's one point there, you see? There's one x value that's actually the smallest. And that is -4. Okay? So it turns out that the values of y that are on that parabola, they're not all real numbers. They, in fact, go down as far as -4 and anything above, but there are no y values on that graph less than -4. So you would have to put in a restriction here. And the way you would write that is you would say y must be greater than or equal to, because it can equal -4. It does get down that far. -4, okay, comma. You still have to say what type of numbers they are. And because the y values, they're decimals, fractions, they can be anything really. They're all real numbers as long as they're greater than or equal to -4. So there is your range. Y, values of y such that y is greater than or equal to -4, and y belongs to the real numbers. Okay, so that would be your range from that graph right there. Later on, we're going to be looking at domain and range from the equation only. Although you could just draw the graph of it and see what your domain and range is from your graph if you wanted to. Okay, time is ticking by. I think I'm going to have to probably make 2 videos for this topic, and that's fine. Let's look at graph number 3 now on page 8. And this one, let me see. Now, that's not a parabola. That's not quadratic, and it's certainly not linear. This time we have an x to the power of 3. That's what we call a cubic function. And usually cubic functions, in general anyway, they give you kind of a sideways S shape, like so. Or sometimes it kind of comes up and just flattens out and goes up and down. But you get that sideways S shape. So if you take these x values now and put them into your equation, I'll just tell you quickly what y values you get back. Putting in -2 gives you back -16. Now I can see they've also made a nice scale for this set of axes, all right? And you probably should do the same thing in the examples, the practice when you're doing your cubic. -1 gives me back -2, 0 gives me back 0, 1 gives me back +2, and x equals +2 gives me back +16. All right, so let me just move down a little bit here. Now let's graph these points. -2, -16 is right there. Okay, approximately. -1, -2 is right there. Now note your scale. Be careful with your scale. 0, 0 is the origin, right there. 1 and 2 is right here because of your scaling. And 2 and 16 is up there. And look at that. By golly, that certainly looks like a sideways S shape to me. So now as carefully as you can, draw a nice curve through those points, something like that. There's your sideways S. Okay. Your domain, well, every real number, 2, 3, 1, -10, they've all got a point somewhere on that graph. So your domain is all real numbers, everything. The range, the y values, is also all real numbers because that graph goes up to infinity and down to -infinity. That's a good way you can look at domain and range. Domain is how far left, how far right, and range is how far up, how far down. So there's your range there. Now I'm going to have to stop there because the video time is almost up, but I'll continue this. I'll put up another video now, part 2 of drawing the graph, and that will include the example on the bottom of page 8. Okay, so I'll see you in just a moment.